I'm Chuck White. I'm CTO and founder of Fornetix, former Army officer, veteran of Afghanistan and Iraq. And I'll start with a little bit of a story about device identity. So I'm going to do a couple stories here, but this is the one that kind of gives you some background. So there I was on top of the governor's palace in Kandahar, Afghanistan, rekeying a satellite radio, getting shot at. Said there's probably got to be a better way to solve these problems. Unfortunately, that was like a long time ago. But one of the reasons about the story that Louis and Ari have been talking about are sort of a natural conclusion to go to solve those problems. And what I really want to talk about today in this journey is about what this means when you have this convergence. These things about device identity, human identity, and how it all kind of can come together to actually prove out a useful, technical, secure collaboration of those sort of things, so you can actually build trust. So a few topics we're going to talk about today. I'm going to talk about last night. That is a recent entry, but it is, everything happens for a reason. And so I'll talk about a little story what happened to me last night. And then I want to talk about some of the traditional ICAM, the building blocks that we're using today to build out these architectures for enterprises. And in the case that was brought up earlier, disconnected states. And then the embedded environment, the conversation that Louis and Ari have been really outlining the fundamental components. And then finally, what does it look like? What would be the process if you brought it all together? And talking about that in a way, so I'm going to be really focusing on the broad topics and sort of making this to the understanding, because a lot of this is, people say a lot of things, but I want to get some concepts out there so that we understand why the implications of what Authenta is so important and how it creates a natural bridge for what we're already doing in identity systems today, for people. So I literally got this, if you're looking at the time, that would be yesterday, last night. Mr. White, sorry for the glitch in the digital key. Sorry for the inconvenience. So we have a device identity, my digital key that I got through Hilton. And then there's the fact that there is the identity system that represents rooms for who's in a room. The two systems were not connected, apparently. So there I am at midnight, laying my weary head. I'm from the DC area, so I'm trying to get, my mind thinks it's like around 3 a.m. My door opens. A poor gentleman who was just he was probably more tired than I was, literally came into my room while I'm asleep. And why is that? That is because the antithesis of what we're talking about today actually happened. Distinct forms of identity that should be connected were not. And a gentleman, a weary traveler, got a totally bad Goldilocks moment when he found someone sleeping in his bed, which would just happen to be me. So I want to say that is the world we're living in now and why identity becomes critical. So what am I talking about? Identity, credentialing, and access management. There's things like ICAM, a whole bunch of NIST directives about it, about how to build out these systems. But really what it comes down to is identification, authentication, authorization, by audit. You need to have that. So the data, the traffic coming from this all becomes very critical, whether it's networks, applications, services, devices, people, all kind of builds up to that. And why? To build trust. Now, I'm 10 minutes or 5 minutes. I've been talking throughout the conversation. There is a term I haven't said yet from the audience. What term am I dancing around right now? Anybody? Zero trust.
Could go in.
We didn't want to say it.
I
promise
we're
you did it if
conditioned.
we said it, so we can't say it.
That's fair. Okay, fair enough. And the reason that I'm dodging that term is we're talking about the fundamental components that actually do it, without going out and just saying it because everybody else does. So here's an architecture. You'll see some components. The things in purple are things that Fornetix does. Attribute-based access control, control of PKI, cryptographic services. This is an ICAM architecture we're implementing for the Department of Defense. And so things like automated account provisioning, master user records, identity providers, privileged access management, These are all things you see in human identity, protection of networks, protection of systems, protection of how you're getting the data today. And you can project that to things like PK, tying into PKI, tying into services. And yes, tying into things for network micro-segmentation and API access and all those zero trust components that people are really into right now. That denotes what the foundation is of having identity and then building your rules and things along that. I'm not going to spend too much time on this. We're going to move on here momentarily, but the idea being more than anything else, this is a modular open systems architecture, building blocks. Because what we've come to realize, just like the collaboration between Micron, Trustify, Fornetix, and our broader coalition of the willing, is the fact of the matter is nobody has a complete solution. And so building out these technologies, solving these problems, keeping some guy from coming into my room at midnight takes a village from a technology perspective. And that these components, though, can be maybe not employed in every use case. We talk about a disconnected state. I mentioned the term earlier, DDIL, denied, disrupted, intermittent, and latent communications. That's not just a government problem, it's also a commercial one. And noting that you have architectures to support that, those building blocks may be employed differently depending on your architecture and what you're trying to do. This is something you could do at the enterprise. It could use cloud services. It can be done on 4 laptops in Coconut Island in the middle of Hawaii. That was 2 weeks ago. But the idea being, it provides an architecture that allows to connect and build trust for identities. Now, I'm going to take this architecture and I'm going to pivot it 90 degrees counterclockwise. Because when we start talking about devices, it's about the association of taking the PKI, that trust, that's at an institutional level, and connecting it down to the devices at most fundamental, the roots of trust at a device. And so when you think about identity on the IoT or the OT side, the device side, it's very much integrity-centric, where the previous architecture around human identity has integrity, but there's also a nice bit of confidentiality built in and availability. We've been kind of talking about various architectures to support that the entire time. Now, why is this important? Is that you have things like policy decision points and policy enforcement points. Builds out into that architecture. How identity is established becomes a decision, a policy decision. And that provides that root or that connection into the broader idea of that access management component, and it becomes fundamental because it's cryptographic in these embedded systems. It's simply enough, if you're going to have something, we talk about the IoT projects that are being worked on, and the idea of what that might mean and what that trust model looks like. You're not going to have enough gates or memory access or along those lines to be able to make a complex authentication or authorization decision. So it comes down to everything that Ari outlined previously about the components in the memory being able to execute cryptographic transactions. And why integrity versus confidentiality? Well, you can load the confidentiality components on top of that, but if you're talking about identity, you're talking about building trust, you need to be able to actually start with something. And that's why this component of authentic becomes so critical in this architecture, and how the team at Trustify of Triathlon platform provides a means to connect those abilities in. And then you notice he mentioned the Fornetix secure platform earlier. Well, that opens the door for a few different things. One use case, and we're going to talk about this, the idea of where you talk about that secure appliance being applied with triathlon. And this answers a question that was brought up earlier. You have an out-of-band delivery mechanism of that trust separate from the supply chain. 2 distinct paths. So something is out of band of the other. And that allows you to have points, and that's sort of like where you have a federation model based off of those cryptograph, those keys that represent identity. Separately, you have the supply chain model for where the widget goes from point A to point B, or it gets built up, in this case, into a pickup truck. But the idea being of the separation with those activities, those things like attestation, those HMAC operations, being able to validate things become part of how you say, this thing is okay as it goes through my supply chain. And as it builds up for building trust, I have that I have that audit. I have that ability of seeing that these things actually happened. And that's the trust component that becomes important over the history of the device. And so that becomes a critical tenet of this when you think about it from an identity perspective. In the case of embedded and IoT or OT, how you trust that device becomes how you trust that device over time. And that's that supply chain component that's so critical in this. But besides the security components, it also opens the doors for monetization. That's actually a neat thing about identity. If I know who you are, I know what I can give you. I have ability to meter things and provide value based off of how you've been identified, authenticated, and authorized. And having that so that the actual individual embedded components are supporting that type of operation becomes critical in terms of delivering value. You could even make the case economically, it keeps costs down because you have this integral, I'm going to say it, digital rights management embedded at a silicon level that can be used to say what you actually get. Going back to the car seat issue with BMW that Louis brought up earlier in the conversation. But I want to take this a step further. What happens when you weave it all together? The idea being what you see here is that you have two distinct paths being demonstrated. The one that drives human identity and its components from end to end. And then the part that provides the device identity and how it maps in, particularly around things like cryptography and attribute-based access control, into the broader ICAM architecture. So you have traceability there as well. And so if you think about it in this use case, and the architecture here is supporting supply chain and service delivery for an automotive manufacturer. The fact that you can actually track something and ultimately at that end state between the customer and the Authenta, protected or Authenta enabled device, you can create traceability between an identity that is the person and in the identity that is the thing. And that alignment becomes critical in terms of building out these architectures. So now you can say, I'm not just looking at how I trust a person, I look how I'm trusting a person in light of the devices he actually has associated with him. And that's the big piece of this that's critical to understand. Whether it's continuous validation or it's being able to say, I can now assert these identities from my devices in my infrastructure so that I can assign people to them and I have tracking of that as well. Or if you're talking about from network architecture perspective, I can provide identities from my network devices, the physical infrastructure that is providing a service, and be able to tie that into my broader human identity infrastructure so that I can create associations, or I can say, this is the micro-segment this user gets because I know what the device is he's trying to work on, I know who the user is, and know for my campus area network, I can do that on the fly because I have trust coming from both places. And so what was fun about the conversation to date, the concept here, you notice a lot of the things that Ari and Louis were talking about. If you just don't say it's a semiconductor for a second, are very similar concepts when dealing with human identity. I mean, a lot of the conversation we've been asking questions on today are frankly ones of federation. So the beauty of it is that you can see common solutions to common problems. And I think that's a big part of what makes the Authenta solution so interesting. Different from the TPM story, different from other stories out there for like, you could say what like Intel is doing with SGX. Is that it has the ability to federate in the same fashion that human identity systems federate. And being able to create that association allows you to be able to do combinations, be able to take advantage of that modular open systems architecture and build out complete identity architectures based off the common combination of person and non-person entities.
So I have what's probably a fairly basic question, but so you've talked a lot about the keys being held with flash. Is it that flash device that you're creating the integrity for, or is it the entire system in which that device is plugged into?
It's the latter,
Okay.
but it's first the former. In the beginning, you can authenticate the silicon. You can say, oh yeah, it's not a counterfeit. It came from a trusted party. But then when you start the programming, you're putting system content to it. It's becoming the personality of the system, the operating system, the applications, and maybe some data.
The platform.
And then you can actually take the imprint of that and say, I can authenticate these two things combined.
Okay.
So you can do the latter after
So
that.
once you've manufactured, so let's take this truck on the screen, for example. So we've put all the pieces in, we've put the seats in, we've loaded the software into the onboard computer. Now we're essentially going to like hash that entire setup.
Yep.
And wrap it up in a bow, send the key of that up to the cloud, and now you got your separate paths.
Or locally or federated in your own infrastructure. Cloud is and that was the part to talk about. Cloud absolutely is an option. But the same token, if you don't want to do that, you can take it similarly, you can federate that to the next hop and leverage it there.
Okay. So if I'm manufacturing this truck, if it's a Toyota truck, it's being manufactured in Japan, we're going to send the physical pickup on a ship east, and we're going to put the key onto a USB stick, and we're going to send it west.
Or you're going to have connectivity to the next hop.
Yeah.
And then mutually authenticated TLS federated, send that over an encrypted channel. You could sneaker net it.
Yeah.
Sure.
Let me clarify something about the keys. There's no keys being shipped. So you talked about the truck, you put all the modules in there, you configured it and gave it the personality. What you do there is you register. You register this one combination of the software, and the type of flash, and you do a hash and you register that. Okay. So when you register that piece of information has to go to the authentic cloud. Right. Now you're going to actually take this configuration and you're going to do fleets of it. The fleets of it are going to have separate keys because they all have separate silicon that have unique keys. But they'll do that same configuration. They'll do a way to generate the key where they hash it and they do a public derivation of they do a key derivation function of the private key, public key pair, and then it becomes a certificate, right?
Yep.
We actually can digital twin boot that. We can actually do a digital twin representation of that process because we had the registration done. So now all those cars that go out west, they just have to go to the cloud to confirm that they have the right configuration. So it's actually simpler than I wanted to lay out, that there's no keys because there's a digital twinning that occurs by this federation party.
Okay. Makes sense. Thank you.
Yeah. So this infrastructure is what every enterprise has. The US government has that for all their government employees. The military has this for all their forces. And enterprises have it for us in Micron. My name is associated with a title, pay grade, and policies that allow me to access something or not access something. Well, now, if you can leverage that and put the identities of things in there, all of a sudden you're just making it so simple to be able to manage, because there's 6 billion people, but there's over 20 billion devices, and there's going to be more, right? So where do we put those things, and how do we make policies for them, and how do we control them, monetize them, and also protect them, right? So that's what this connection is about. That's why this is so important. We're leveraging infrastructure that exists.
Exactly. So that association of device, person and non-person entity becomes critical because that combination can ultimately determine an access decision. The combination can ultimately determine what functions get turned on. And so all that capability that gets built into this is the idea being that now there's a consistent path on the device side to maps to the building blocks that already exists on the human side. And the combination becomes gives you a whole new universe of options to build trust in a way that is not computationally expensive, to the point that, that Ari made earlier, it is relatively, it's something you could implement easily. And because of the way that the Micron technology is distributed globally, on the device side, it's the fact that it's ubiquitous, and that's critical in being able to use that as a foundation. And I think that's something that being able to address that as a point is now you have a way to map the IT universe to the OT universe in a coherent and consistent manner, and that's going to be really big as we go forward. Because IT and OT, as they're blending more and more together, there are going to be there's a universe of pitfalls, just the DDoS attacks based off of hacked, IoT devices, guys coming into your room at night because your key isn't, two identity systems aren't synchronized, or even the fact that you have the, features and devices for, these technologies like automobiles, where you want to be able to map a user to an identity because there's so much more compute and services being delivered in the vehicle, that you want to be able to create that association so that you can actually make sure the right person is doing the right thing on the right stuff. And I don't think that in the fact that we can do that now, thanks to what we're talking about here, is really huge.
So kind of the elephant in the room. What happens in, say, 10 years, Micron decides to turn off the authentic cloud? Do these devices stop functioning? Do they lose significant functionality?
Yeah, so I think in the beginning, I mentioned that the keys are there. They were what programmed in the silicon manufacturing process, but we institute a ownership change methodology. So with that same crypto key, you can assign a new crypto key to be the controller of the flash. So it's our goal that these systems get controlled by the end user eventually. The digital twinning part, there's also ways to deliver what are the initial secrets to create certificates so that the digital twinning could be done. So there's nothing that's going to preclude other parties from doing what we do. In fact, what we want to do is promote this methodology beyond just Micron. We're actually letting other memory vendors use the AutentiFlash, licensing the AutentiFlash IP, so that other memory vendors will create AutentiFlash. We will be also working with other cloud companies that would want to institute a service. That's a little bit more in the future, because right now we're still building this up. But yeah, this is not going to be just Micron.
Okay, so once an OEM swaps out the keys that you guys ship it with their own keys, Authentic Cloud is out of the picture if they want it to be.
If they wanted it to be. Correct, Michael?
Okay.
That's that better.
It's still dependent upon the Micron cloud, the OEM's cloud, some cloud to be able to authenticate and verify the keys to make the services function.
Necessarily. That one of the use cases we're talking about working with the RE's team is that you can actually take that ability down to a disconnected state. So that's why architectural considerations of things like DDIL, denied, disrupted, intermittent, and latent communications, becomes critical in what you select for your architecture, because that is a big part of it. The cloud gives you a degree of convenience, absolutely. But if there is a desire not to depend on a cloud, the architecture is able to, what you can do with the triathlon platform, this idea of a machine integrity manager can be done in a disconnected state. So the option is there. Cloud always gives you convenience. But the idea being, if that is something that's seen as a risk, that federation model that we were talking about earlier can be applied to take it off of a cloud environment into a internal sort of back to traditional data center operations.
Yeah, cloud is a convenience as long as A, you can get to it,
Indeed.
and B, it works.
Indeed. Amen. That's actually that was one of the things that we've been working on, and why the fact that I could take this architecture I'm showing here and I can make it disconnected and it can still work.
How do we deal with conflict of ownership here? In the sense of, I've got a device manufacturer who is selling me their stuff and they're putting all of this in place. They're making sure no one can mess with it. And I, as an end user organization, want to likewise make sure no one messes with the stuff I'm putting on there.
Yep.
But my manufacturer has said, we don't want you messing with our stuff, but we want to mess with the stuff because we own the stuff. How does that play?
Interesting. So very, very good point, because as a system OEM, and I'm making a system and delivering it to you, I want to make sure you don't mess with my stuff. Otherwise, I lose the ability to function the way I want it to function.
Mm-hmm.
So there's some inherent need that they have. The customer has inherent need to do personalization of the system. No one's going to build a system that just meets their need. So one answer is the memory, authentic memory has multiple ownership capabilities. Right, an initial generation is 8. So you can partition where is the ownership, and you can divide and conquer the memory based on different cryptographic keys. So you can isolate it that way.
So it's kind of a first come, first serve. So the OEM builds their ownership, they build the things they want to protect,
Yes.
and then you inherit as the second owner, and you can touch anything except what they want you to touch.
Because you don't have their cryptographic key.
Right.
Correct.
So there is a potential for customer lockout in this, but we get to control anything our vendor says we're allowed to control.
Yes.
Okay.
But also, sometimes as the buyer, and this happens a lot, if I'm Amazon and Google, I'm going to want to do whatever I want. Put what you want in there, but let me be able to obliterate it because I like to do it myself. And that's a business relationship. That's not a technical problem, because the technology will allow for that.
So the technology will allow me to, if I bought it and my manufacturer has said this is what I'm protecting, I can still blow it out. It just won't be supported by the manufacturer anymore.
Whatever your business relationship allows.
So I still have to get their
Yes.
permission.
The business owner, the manufacturer will have to give you a signed command, and you take it, and then you execute it and allow the system to change control to you. So there's no technical hurdles here. It's all about business.
It is all about business.
It's I was going to say it's the big P policy problem versus the little p policy problem.
Mm-hmm.
You know, the technology is an enabler, but the business process is what really becomes a limiting factor, or the enabler, depending on how you look at it.
Yeah, it just opens up the potential for interesting headbutting between businesses where you know the John Deere DRM stuff and all of that, whereas my manufacturer has said I'm not allowed to do that. Well, I want to do that. Manufacturer goes, no, and you're done here.
Yeah.
Yeah.
And that's becoming a legal situation now.
Yep.
That whole thing is in the courts right now.
And you guys have made multiple references to the BMW seat heater thing, which is running right up into the smack of regulatory things. And what you're going to quickly find out, and what the companies are going to quickly find out, is that monetization is great. The FTC is greater, and they're about to slap consent decrees all over things like car manufacturers. I get the idea of some of this. I would share concerns that this, at this time, until the right to repair things are, this platform could accommodate right to repair, but the pitch that I'm hearing is like, I think that it raises concerns as someone who supports the idea of right to repair that, okay, well, if the people I'm buying the car from have incorporated this platform, they've locked things down to the point where I wouldn't be able to repair it, or my tractor, or whatever. It does seem like it would, it would almost make me want to make sure that I disable any radios in the car that can transmit.
I will say, as someone who is a huge right to repair proponent, have donated to the cause. This is not the problem, right? The problem is how people choose to use this
Business.
For sure.
right?
Yep.
We need this functionality to make our products more secure, more trusted. Again, how people choose to use that functionality, yes, we can disagree that there are, that we shouldn't, be able to do that thing. Doesn't mean that we don't need this.
Let me throw another curveball on right to repair. Safety. Because for key systems, you think about electronic control units in a car that can drive itself. Do you want, the idea being the counterpart of this is the safety versus security concern. A manufacturer can use this to say, this is my integrity, this is my device identity for this component and service that makes a decision on what this car is going to do when it sees an ambulance. And do we want to give this is like anything when technology provides a new path to be able to do things. This drives these questions. And what I feel, because of the integrity-based play that Authenta delivers, particularly in like critical infrastructure, it ends up creating a safety versus security argument that kind of goes around what the nature of what we're talking about here. If a manufacturer locks something down, just for the sake to not let you mess with it because they want to make you pay money, that's where I think the right to repair thing is going to come up. But what a manufacturer could also do is saying, here are my critical components that make this device work the way it's supposed to, because it has a desired outcome. It might be a medical device, might be, the self-driving car, might be a missile system. Pick one. Point being is that there's expected, just because you can manipulate something, this also provides safeguards to say key components that have specific operational characteristics can be protected. The integrity of those services can be attested to. And then how that ties into the broader idea of the people who are doing the things, that's another interesting association that this delivers. And that's why we talk about it from the ICAM perspective, Identity, Credentialing, and Access Management, because now it's saying what happens when devices have identities that can be attested to. What can you do with that?
This also provides the paper trail in that if you've gone to the manufacturer and said, I want you to open this up, and the manufacturer said, you're on your own if you do this, you've got the paper trail saying they signed.
Exactly.
And it's their responsibility, and it's on them any legal requirements that come out of this.
Which is a huge positive, I believe.
Yeah.
You can't allow, it provides you that integrity that notes, I have done a thing, and I can attest to the fact that I have done this thing.
And this is good for closed systems. For open systems where you're just trying to, you've got your PC, it's got its flash, and you're trying to keep a corporate policy going. If you have a dispute with the manufacturer, this is flash-based. In most cases, swap out the flash for a new one, and you're done here, unless you're Apple and it's embedded on the board. But that's another story. But the thing is, the closed systems, like your Teslas and your F-150s and all of that stuff that have everything locked in, you're probably not going in and replacing the flash chips on those. But, your average PC, if you've got a problem with the manufacturer, new one.